Last time we talked about the multiplication rule for exponents. And just to review, that rule was if you multiply bases that are the same, okay, and we remember that whenever we write a letter with no exponent that's understood, there's an exponent of 1. When you are multiplying and these bases, these are bases. The x is a base. The x is a base. They're the same. When these bases are the same and you are multiplying, you add the exponents. And so that's the multiplication rule. X to the 2 plus 1, or x to the 3, or x cubed. Okay, that's the multiplication rule. So, let's say it again. The multiplication rule was when multiplying and the bases are the same, you add the exponents. Well, just like that multiplication rule, the division rule is just basically like the opposite of the multiplication rule. Okay? We get a different marker. The division rule, which we'll write here, division rule for exponents, okay, here's the division rule. First I'm going to show it and we'll see if we can derive it just from watching it happen. We are going to divide x to the third power by x to the first power, okay? So this fraction bar means division. So x to the third divided by x to the first, what we'll do is we'll write equals x to the 3 minus 1, which equals x squared, or x to the power of 2. So I bet you can tell me what the rule is, right? When you are dividing and the bases are the same, you subtract, okay? So we could say when dividing, we'll build this rule up, and the same bases okay? When dividing with same bases, subtract exponents. And that's the rule. I'll write it all out as a single sentence here in a second. One thing to remember is you always subtract the bottom exponent from the top exponent. The order is important, so it couldn't just be flipped. It had to be 3 minus 1. Okay, so there you go. So let's write it out in a whole sentence form. I'm going to erase this in 3, 2, 1. Okay, here comes the rule. When dividing numbers or letters of the same base, subtract the exponents. Okay? So here's the full division rule. When dividing numbers or letters of the same base, subtract the exponents. So this is kind of the key word. Subtract when dividing. Okay, so the pattern here is when multiplying, you add the exponents. When dividing, you subtract the exponents. Let's do some examples. Let's do 3x to the 5th power divided by 6x squared. Okay? Well, first, we're going to deal with these numbers. So for just a minute, I'm going to act like there are no variables. And I'm not going to worry about the division rule. I'm just going to look at 3 over 6. Well, 3 over 6 reduces down to 1 over 2. Because I can divide a 3 out of the numerator and denominator. Okay, so I've got part of my answer is 1 over 2. Okay? Now, what's going to happen here with this x? Let's do it. So we know that if the bases are the same and we're dividing, let's check. We're dividing, yes. Bases, x, they're the same. We're going to subtract the exponents. Now, here's the important thing. The question comes up, where do I write the x? Do I write the x on the numerator or in the denominator? Okay? Well, to a certain extent, that depends, but since this is our very first day doing this, I want you to write it in the numerator. Okay? So, we're going to write x up here. 5 minus 2. So in the exponent position, you do 5 minus 2. All right, so we're almost done. 5 minus 2 is 3. So this equals 1x raised to the power of 3 over 2. It's fine to write it like that. You could also, you don't have to write the 1, so you could write it like that, x to the 3rd power over 2, or you could write it like this. You could put the 1/2 out front and then write x to the power of 3. All 3 ways of writing it are equivalent. Let's do another example. Okay? Let me make sure I give a moment. That example may have been a little bit too much to throw at you all at once. Let's try one without the numbers. So let's do y to the 9th power over y to the 3rd power. Okay? So we're dividing y to the 9th power by y to the 3rd power. Well, the bases are the same. We're dividing. Let's subtract the exponents. So we're going to write y to the power of 9 minus 3. Well, 9 minus 3 is 6. So the answer is y to the 6th power. Okay? People ask, what happened to the denominator? Well, you subtracted it away. And so because it ended up being a positive number, there is no denominator. I mean, it's like y to the 6th. You could write this. Y to the power of 6 over 1. My question is, why would you write it that way? It's just y to the 6th power. Okay? Let's do some more examples. Okay, here's another example. Let's do 3x, open parentheses, 2x minus 5x, close parentheses, all divided by x. Okay? So, first we're going to look inside the parentheses and we can subtract 5x from 2x, and that gives us negative 3x. Okay, so I can just, instead of writing 2x minus 5x in there, I can just put negative 3x. Well, now I just have to multiply 3x times negative 3x. So 3 times 3 is 9. 3 times negative 3 is negative 9. X times x is x squared. Okay, we add the exponents. So, 3x times negative 3x would be negative 9x squared. All right? So up in the numerator, we just have negative 9x squared. Okay? And in the denominator, we just have an x. What we need to do is remember that there is a 1 in the exponent position of that x that's all by itself. And now we can apply the division rule. When dividing numbers or letters that are the same base, x, we subtract the exponents. It doesn't matter that that negative 9 is there. It's going to just come along for the ride. And so we're going to write negative 9x raised to the power of 2 minus 1. Okay? 2 minus 1. Well, 2 minus 1 is 1, so the final answer would just be negative 9x. Okay? Let's do another example. Okay. We have 5x to the 12th power minus 3x squared. No, I don't want to do that. Let's do another example, okay? We're going to have 5x to the 12th power, and we'll write it this way this time. We're going to divide by x to the 7th power. Okay, well, nothing changed. We're 5x to the 12th power divided by x to the 7th. You could just rewrite that. Instead of writing divided by x to the 7th, you could just put a fraction bar and x to the 7th. All right? That's another way to write that. But to do this problem, when it's written this way, it's actually easier because you just say, all right, this is equal to 5. Since I'm just dividing 5 by 1, I just get 5. And then I write x, 12 minus 7. Well, 12 minus 7 is 5. So this is 5x to the 5th power. All right. Final example I'll show is one that has a fraction. We'll do x to the 7 over 2 divided by x, just x, okay? Well, remember, there's actually a 1 in this position, and we can rewrite 1 with a denominator of 2 by writing it x to the 2 over 2. So now we're just going to perform the same thing. This is equal to x raised to the power of 7 over 2 minus 2 over 2. Okay, so just perform the subtraction. You subtract the numerators. The denominator stays the same. You have 7 minus 2 is 5 over 2. So the quotient would be x to the 5 over 2. Well, with this, I think you're able to answer the questions on your homework. Please let me know if you have any other questions. Otherwise, thanks so much for being a tremendous audience. You guys have a great day.